Hi, this is Randal Schwartz, host of FLOSS Weekly. This week, Dan Lynch joins me. We're going to be talking about a way to get emissions data from all over the world using satellites. You're not going to want to miss this, so stay tuned.
Podcasts you love.
From people you trust.
This is Twit.
This is FLOSS Weekly with Randal Schwartz and Dan Lynch. Episode 555, recorded November 13th, 2019. Emissions API. This episode of FLOSS Weekly is brought to you by Hover. Use a domain name that truly represents you and your passion. Visit hover.com/twit to get 10% off your first purchase of any domain extension for the entire first year. And by Melissa. Bad data happens to good companies. That's why 10,000 businesses count on Melissa for clean, reliable address data. Get started today with 25,000 records cleaned for free at melissa.com/twit. It's time for FLOSS Weekly, the show about free, libre, open source software. I am your host, Randal Schwartz, Merlin at StoneHenge.com, bringing you each week the movers, the shakers, the big projects, little projects, futuristic projects like today. This is going to be really cool. And just random stuff on some shows. Sometimes we just talk to people. So joining me once again is my lovely and talented co-host, Dan Lynch. Dan, and welcome back.
Hi, it's good to be back.
And where are you speaking to us from? Probably Liverpool, right?
Yeah, I'm in my little studio here in Liverpool, in the northwest of England and the UK. It's very wet here at the moment. We've got flooding and they've had a year's worth of rainfall in like a month. In like a couple of days apparently. So it's cool. I'm glad to say I'm currently obviously not underwater. So if that happens during the show, that may be a problem.
Right, and I'm speaking to you from my home, which I'm at occasionally. I was here, I think, 2 or 3 weeks ago, doing a show from here. If you're looking at the video, you may notice something a bit odd. And it also will explain why I wasn't actually on the show last week. For some reason, my skin on my face got extremely dry, maybe about 3 weeks ago. And I wasn't realizing it, but I was biting my lip a lot. And it was essentially trying not to be too gross, but it was basically getting peeled back. And so I had a whole row of blue bars across there. And it was just like, I said, I don't want to subject people to that. That seems really, really bad. So, but this week it's better. It's much, much better. So I just wanted to explain that for people who are watching the video. And if you have any recommendations for good skin creams to get rid of dry skin, I'm now searching for that. I'm going to be stopping by a drugstore later today. So this week's project is interesting. I was reading through the notes. I was like really amazed at what they're actually trying to accomplish. The project is called the Emissions API, and we're bringing on in a few minutes Lars. I should have asked you guys how to pronounce these before we get started. Lars, Kiesow, something like that, and Timo, Nogueira, Brockmeyer. So that's going to be fun. And they'll be coming on in a few minutes to talk about what this is. So from what I gather, there is publicly available data that's out there because it's sponsored by governments and satellites. Obviously, private people aren't sending satellites up. Oh, wait, now they are. I forgot about the SpaceX stuff. So there's people, there's this API, but the API is rather awkward. You kind of have to be a satellite guy and a bunch of other things. So what the Emissions API project is, and I should tell you what the data is. It's basically emissions. It's like how polluted are we getting and that sort of stuff. So what these guys are doing is taking that data and writing all the software that you need to turn it into a nice REST interface or a JSON interface of some kind. And you can actually tie it directly in the browser to, say, the graph package, which is really cool. So on a couple of the demos, I saw this graphs that were being made with that. This looks great. It's still pretty early in its infancy, but it's already usable. But they're doing it as a sort of a test project right now. They've only got 1 month worth of data in their servers, but that's sounds interesting. So, Dan, what do you think?
Yeah, I was having a look at this earlier. It is really, really interesting. I was looking at some of the examples they've got on their website, which we'll probably talk about. They've got some examples of some of the graphs per country for, graphing the CO2 output of a country and using the data from Copernicus satellites and stuff, which is really fascinating. And I can't wait to find out more.
Well, then we'll be getting right into the show in just a second. But first, I have a very important message, because this episode of FLOSS Weekly is brought to you by Hover. Hover is a jumping-off point for many entrepreneurs, and they want you to start your business with a domain name that truly showcases who you are. Hover has over 300 domain name extensions to choose from when building your brand online. No matter what you want to build, there's a domain name waiting for it. If you're a designer or creative professional, you can use .design instead of using a generic .com or .biz domain name. By using .design, you're telling everyone exactly what you do. Stand out and brand yourself online with the perfect domain name for you or your business. You'll find excellent technical support available to answer any questions you may have. Their support team doesn't upsell you. They only work hard to help you get online. Hover has free Whois privacy protection, a clean and easy to navigate UX UI, monthly sales on popular top-level domains. It's not hard to see why Hover is a popular choice for people starting all kinds of businesses. Keeping your domain name separate from hosting gives you the flexibility to choose the right platform for your business. I'm a personal customer of Hover. I have, I think, something like 15 domains with them. Pretty much all the Randal Schwartzes are mine. I took like 10 different extensions and just got all of them. So I'm Randal Schwartz everything. Okay, so use a domain name that truly represents you and your passion. Visit hover.com/twit to get 10% off your first purchase of any domain extension for their entire first year. That's hover.com/TWIT for 10% off your domain extension for a full year. And we thank Hover for their support of FLOSS Weekly. Now let's go ahead and bring on our guests. Lars, welcome to the show.
Hi, Randal. Good to be back.
Yes, so you were on back in January, I think, isn't it? Something like that.
Yes, that's true. So it's a completely different project than this time. And I'm still working on the other project. That's my kind of professional career, and this is more a labor of love thing. But yeah. Yeah.
I'm trying to figure out your business model for this. It's maybe there isn't one, but let's also bring on Timo, Nogueira, Brockmeyer. Did I get it close?
Yes, that's about it. Hi.
Hi, and I should ask you guys, where are you speaking to us from?
I'm speaking from Osnabrück in Germany.
Okay, cool. And Lars?
That's the same for me, though I'm in a different part of Osnabrück here. We are both in our respective offices, so we are not full-time working for the same company. But they let us use the office for our own work as well.
Well, I usually ask at this point what the 30,000-foot view is. Tell us what problem you're trying to solve when you do this. But this time I have to ask, what's the 300,000-foot view, right?
In a way, yes, that's probably true. There's a longer story behind this, and we probably get to this. But we are interested in this public interest technology, and we were always interested in space in a way. Though no one of the core members of this team really is I don't know, a space engineer or whatever you call them, these fancy people from NASA and ESA working on the satellites. We got interested. We heard about this data being available publicly, though it's actually hard to interpret and hard to work with. And so we thought, well, maybe we could do something to make it easier for people to build cool projects on. And I think we all have ideas for cool projects we could build on this. And this is more or less, or Emissions API is more or less laying the foundation for these kinds of projects. We're getting data from the European Space Agency. It's their Copernicus program with satellites called Sentinel, and they are monitoring the Earth and getting emissions API for several different emission types, like, for example, carbon monoxide or ozone or stuff like that. And making this available for everyone, I think, especially in this time, it's really interesting.
Yeah, and when I first read about this, I went, wait a second. So they're satellites, right? So they're up there. How can they detect anything like CO2 or carbon monoxide or anything like that?
Well, obviously they cannot measure the levels on the ground, but what they can do is they have hyperspectral cameras on the satellites, and so they can measure the different wavelength in the air. So basically in the column from the satellite down to the Earth and back again. And from the ratios between the wavelength, you can infer about different chemical properties and concentrations. So that is basically how it works, very simply.
Well, I was going to say that is rocket science.
It is, and it's worth mentioning maybe that we are not doing this rocket science, so we are not qualified to do this rocket science. What we are doing is ESA does provide the raw measurements of the spectral wavelength, but they also provide the data products that are derived from that. So ESA as well is developing the algorithms to transfer these raw measurements to concentrations of the chemical compounds, and we are using these derived data products from ESA.
Okay, and so how did this get started? Somebody on your team tried to use the data and it was kind of awkward to use?
I think some people of us have heard of this kind of data or had some kind of contact, maybe not directly, but with other people. And we were just thinking, how could you utilize this data? And basically for us, the answer was, well, we can't. It's just too complicated to put it in an automated environment to kind of build an app directly on the service from ESA. So there was some kind of infrastructure missing, and that was one of the ideas that for us was the trigger to say, okay, well, then we just build the infrastructure first, and we'll see what happens next.
Go ahead.
Go on.
Okay, and maybe it's important to say that we already had this idea, and there was something else playing into us actually getting this off the ground, and this is a fund provided or indirectly provided by the German government. So they have a very, very cool project. It's called Prototype Fund, where they help get open source projects off the ground. You talked about business models earlier, and they have the special requirement that they will never fund any companies, but they will fund private people here interested in this public technology and help them get these stuff off the ground, both with some basic training in project management, if you want that, but then also with a little bit of money so that you can actually say, okay, I can step down a little bit from my regular work and have this cool idea and try to do that. And so these both came together. So we had an idea, and we are not only Timo and me, but we are actually 6 people so it was a core group who started this, and we discussed it, did some brainstorming of how we could approach this, how we could do this, how we could get this whole thing off the ground. And then we applied to this grant, and they said yes. We are interested, so please try. And that's how we got started, which, I think that's very cool. And this also means, we're not very old. So we started roughly 3 months ago. You mentioned earlier that there is already an example and there is already an API, but it's still more a prototype API with very limited set of data. And there's a lot to do when it comes to getting this off the ground properly, because we're dealing with a lot of data. So we start with just a simple server we could rent ourselves, but we are actually talking about not megabytes, not gigabytes, more a terabyte of data or something like that. And it will be more in the future. So we're trying to figure out how to actually make this work for a long time and stuff like that.
That sounds really great that you've got public support as well from the government. That's fantastic. They're supporting this kind of work. You've actually almost kind of preempted one of the questions I was going to ask you there, because I would imagine that you mentioned terabytes. There's a lot of data that you need to process and store and all that kind of stuff. So obviously you're at the start of this project, and that's only going to keep growing and growing and growing. Is that a concern, the amount of data that you're going to have to store and how you're going to get the infrastructure to keep of all of this?
Definitely, yes, it is. First of all, so we don't keep all the data. That's one of the important things to say, I guess. If you're a scientist which is really interested in very, very specific parts of the data, then you probably know how to get this from the user directly and can work with it. So we are more interested in the broader stuff, like getting the carbon monoxide value, but not asking the question, where was the satellite specifically at this time, and what was the status of the satellite when it takes this measurement. So we are dropping parts of this data as part of importing this. And so we can already reduce this, but still it's a lot of data right now. I think Randal will be happy to hear that we are throwing this in a Postgres database because they have a very great extension called PostGIS, which is especially for working with these geometry data. But we'll end up with a very big database, and we are trying to talk to institutions who hopefully interested in keeping this up and running for a longer time. Actually, today I talked with a university who are just building their new data center, and I thought, well, maybe they are interested in getting this off the ground, because they are also should work in the terms of public interest, especially since here in Germany, basically nearly all universities are state funded, so they should theoretically do that. They don't always do, but and getting someone like that to host this in the end would be really nice, because historically, basically every German university has their own data center, and for them, they are used to a lot of data because they have a lot of research data. And then the other thing is that, yes, we are targeting developers and somewhat end user-ish level users mainly, but still to query this as a researcher could still be interesting, because you cannot get so much details. You can get access to this data really, really fast. And so even for some of these researchers at these universities, it might be interesting. We are also trying to talk to other infrastructure providers. I guess you may have heard that Amazon is now handing out resources to open source projects. We aren't exactly sure if we want to go the Amazon route, because you're kind of bound to Amazon then, but it would still be an option, and depending on what we use there, you could still build it in a way that you could at the end still have it run somewhere else. So maybe we will in the end also apply for Amazon to sponsor us, but you never know if that is going to happen, because I guess there are more interests this is my personal guess, but I guess they're more interested in helping projects which at the end they can use to run on AWS as a service or something like that, but we'll see.
Yeah, until we get satellite data as a service, maybe that'll be the big thing. Yeah, so I mean, obviously, it's a lot of data to deal with and so on. And we've had Eric Duckman in the chat room. People are chatting away as we're talking. Has brought up. We have this thing on the show where we seem to always end up asking about blockchain. It's a bit of a joke, but he's just saying, have you considered blockchain for storing your data? I'm imagining that's probably not going to be quick enough to access. I'm not sure.
Of course, you know that if you have a cryptocurrency, the European Union and was talking about this emission data and how could one country be held accountable for I don't know, putting out more emissions. So maybe we could use the cryptocurrency for them to pay that off. I don't know. That's the best thing I can come up with right now.
That's not a bad idea. So yeah, I mean, there's talk about carbon credits and stuff, isn't there? So maybe we could work that in somehow where you earn carbon credits. I don't know. Anyway, yeah. But back to the more back to the more serious kind of questions, I suppose. We've had another question from Jay Bennett in the Jonathan Bennett of this parish in the chat room there. He's saying, do you host this API transition? Sorry, let me get this right. Do you host this API translation service, or is this a library that you would download? That's I would download, say, and
run. Right now, we are hosting this ourselves, and we build everything needed for that. Well, it's all based on other open source libraries, but we did build it ourselves. So if you go to emissionsapi.org, you will find the GitHub repository link from there. And there are right now, I think, three interesting repositories, which is the emissions API itself, which is basically the service we want to run in the end. And there are other libraries around that where we thought that maybe it's interesting for other people to use this as well. For example, the ESA has an API thing where you can download binary packages, and for example, we do want to do that not by going to a website and clicking us manually through that website every day. So we built a tool to automatically download these binary data files. You can basically use the same search you can use on the website just with a Python package, and at the end say, okay, download all these products I want to have and throw them into this folder. So that's, for example, something we built, and that may or maybe not be useful for other projects as well. I'll know at least of one other project that already uses this. So long term, we'll see. And we're also trying to pack all the algorithmic stuff into another project. I think it's called Central 5 Algorithms right now. But that's all on the GitHub page. We're trying to be as open as possible with all of this, so that other people can see this, can use this, can make suggestions, can contribute if they want to. We're always happy. And we actually also got already a few contributions, so not a lot, but then we are not very old, so I wouldn't have expected a lot of contributions at this stage. And from what we got, we are already quite happy. And if you're interested, you can use it. You can set it up yourself if you want to, and have spare hardware for a few gigabytes or terabytes of data. I mean, if you're only importing parts of the data, let's say one country, if 1 month or something, we're actually not talking about a lot of data. So you probably end up with a gigabyte or so. So that's something you can definitely do if that's interesting for you.
Cool. Hey, I have a few more questions. Can't let Dan have all the fun. But before I do that, I do have an important message, because this episode of FLOSS Weekly is brought to you by the leader in address verification, Melissa. Every address is covered from Adelaide, Australia to Zimbabwe, Colombia, and everywhere in between. We all know there's nothing good about bad data. It costs money, hurts sales, and decreases customer satisfaction. If bad addresses, duplicate records, and bouncing emails are hurting your business, isn't it time to come clean with Melissa? Delta Faucet, Z1 Motorsports, and Car2Go use Melissa. You should too. Delta Faucet was able to improve their call center processes with global address auto-completion. Melissa was able to reduce the fraudulent e-commerce transactions for Z1 Motorsports by 90%. Melissa provides a full spectrum of data quality protection for your customer data. Verify postal addresses, mobile numbers, and email addresses. Update the addresses of customers that have moved and eliminate duplicate records. Gain additional customer insight into your data with Melissa's analytics. Easily build address verification and customer data validation into your custom application using Melissa's APIs, CRM cloud connectors, and e-commerce plugins. Or upload your customer file for a quick data cleanse. Melissa is serious about securely managing your data. They continually undergo independent security audits, reinforce their commitment to data security, privacy, and compliance requirements. SOC 2, HIPAA, and GDPR compliant. Mailers spend about $20 billion annually in undeliverable mail. Don't lose customers or cash. Make every address count. Bad data happens to good companies. That's why 10,000 organizations worldwide trust Melissa to get their customer data clean and accurate. Get started today with 25,000 records cleaned for free at melissa.com/twit. That's melissa.com/TWIT, or call 1-800-MELISSA to find out more. And we thank Melissa for their support of Floss Weekly. And now here's a question that I actually asked earlier in the side channel, but we didn't get to it. Is the data available for worldwide, or is it just going to be European countries?
It is available worldwide, yes. So it's also maybe worthwhile saying that at the end of this year, the ESA will launch the successor of the Sentinel-5P precursor, the Sentinel-5, and there will be more data available in the future. So with more density, a higher frequency available.
And where are these satellites compared to, say, where the space shuttle flies? Well, used to fly, where the International Space Station is, I guess. That's probably something there. Are these satellites below that, or are they above it?
I think they are below that. I'm actually not sure about the orbit of the International Space Station. So the orbit height is about 800 kilometers.
I got to do the math. Hold on. Yes. Okay. All right. you crazy non-U.S. people. All right. Okay.
I'm sorry.
Come on. Use the American system. It's so much nicer. Yeah. So, with the launch of the SpaceX missiles, they might end up being missiles. Yeah. Starlink. Yeah. With the launch of that, space is going to get pretty crowded, I would presume. And that wasn't a question.
I think it is, yes. And it's probably a lot of figuring out to do who can launch which satellite at which position. And if I remember correctly, for example, the Sentinel-5P is directly following an American satellite. I remember that American weather satellite is on the exact same orbit, just, I don't know, half a rotation apart or something like that. And but that's not for us to figure out, luckily.
Yeah. Other smarter people than me will be working on that, thank God. And is the constellation geosynchronous, or is it kind of like all over, like weather satellites?
So now you can. I would need a ball to demonstrate this. Let's assume this. Let's assume this is the Earth.
Yes.
Maybe like this. So it's round.
Okay. It's a good thing that was empty.
So this is the Earth, and you have the satellite going basically from the top to the bottom, And
Right.
because it's the Earth is rotating, what happens basically is that this top bottom gets basically tilted a little bit like this. So this
Right.
is the orbit you see for the satellite, and because the Earth is rotating underneath this, you have always the same orbit, but it's flying over the whole Earth. I think it does 16. I'm not entirely sure. I think it was 16 orbits a day. So 16 flyovers over the whole thing. There is a little bit more to it because Timo already said that it's doing a spectral analysis for its measurements. And for this, you need a light source, and what's used as a light source is the sun. So you can't measure anything at night. So as soon as the satellite is behind the Earth, then it can't measure anything. So you only can measure basically half of the Earth. And if you look at, we did some animations. I don't think we ever publish any animations. Maybe we should do that on Twitter or something like that.
Cool.
It's interesting to see that, for example, in February, you have no measurements on the North Pole, for example, because it's always dark there. But yeah, so it's more complicated than just a satellite going in simple orbit and can always measure. But that's a rough idea. And as Timo also mentioned, there's a few successor satellites coming up. So Sentinel-5 should be more than one satellite, if I remember correctly. Which, on the other hand, also means that we get a lot more data, which is both good and bad. So good because we have a lot more data to play around with, bad because we need a lot more infrastructure.
Yes, definitely. Yeah, I worked on Iridium, so I do have an idea of this polar orbiting thing. So there's a little piece of me up in space there. I wrote some of the code that's on Iridium.
That's cool.
Yeah, so I can say I have somehow been involved with this. Of course, Iridium failed madly because anyway, that's a long story. You can go look up Iridium online. I'm going to miss the Iridium flares, though, because they just sent up the next generation satellites. Don't have those big flat panels that would reflect the sun at the right time. And I think I saw the last Iridium flash about a year and a half ago where I was. That was kind of fun. Anyway, that's getting way distracted. Actually, we have a question from the chat room. Jen Pinkley is asking spatial resolution.
The spatial resolution on the ground is about 7 kilometers. So the pixel size is 7 kilometers.
Okay. Yeah, and is that then the size of the data point then that you'll be able to
yes.
distinguish?
That is one. Yeah, that is one data point. So you can basically imagine the world as a picture with a camera, and each pixel has a length of 7 by 7 kilometers.
Wow, and is it doing all the spectrum every time in each of those pixels, or does it have to keep switching, like whatever you put, filters or something, in and out?
You have for each pixel you have all the measurements. So from the derived data products, you can have them for each pixel at the same time.
Okay, let me just scroll back on the chat room, make sure I'm not missing anything here so far.
By the way, that is as long as there are no clouds. As soon as there are clouds, you have a problem and get no measurements. So a lot can interfere with this, but yeah.
Yeah. So how often is a position on Earth retaken, updated?
Every 16 days, I think, the satellite passes over the same location again. But as Lars explained earlier, you have this rotation. So you have the band that the satellite measures overlaps for some places. So it passes in so near that direction before, and so you get a greater data density for one geographic location, but it's 16 days, I think, is the cycle time.
Okay, and did you already cover what protofund is?
Prototype fund?
Yeah.
Lars talked about it earlier a little bit.
Okay.
So
I missed that.
That's basically our funding agency, but I'm happy to talk again about it or a little bit more in depth because I actually find it really cool. I find it really cool that there is this opportunity for people like us that can just alongside their normal work get to work on a project that actually uses digital technology to for a greater common good, and that we can just do it and go there and apply with a very simple interface to the usually very bureaucratic and complicated German ministry guidelines. So I'm really happy about them. I'm really happy that this kind of funding exists.
Yeah. So. It does sound really, really interesting, and as I said before, it's great that that they're supporting that kind of thing. I was interested. I don't even know if you guys will be able to answer this, but I'll give it a go. I was talking recently to people about licensing of data, because we were talking about the difference between. Obviously, we all know about software licenses, and there's hundreds of them, and there's all these different things, but when it comes to data, it's kind of different, and that's becoming really a big concern for people now because data is such a big thing. I mean, everywhere you go online, they're tracking data, they're collecting data about you, and what license is that under? So what license is this data under? Do you know that? Does it matter to you? It's just that it's open in some way, or it's publicly available?
It is openly available. The ESA has a copyright, a notice for each data product, how you can use it, but it is especially open to be used in other products and also to be manipulated. They especially allow that in their own license. But I'm not really sure. I think Lars maybe knows a little bit more about this kind of data licensing. So how it compares to other licenses.
Mm-hmm. To be honest,
I
can't really remember. We looked into this right at the beginning, and I did look into data licenses for a few other things we used, and I'm always trying to select only what's either what's very, very liberally licensed. So I really like licenses for this, somewhat public domain. So public domain, the term is actually not very easy to use because it then needs to be related to which state or which government it comes from because of law. And for example, the German law doesn't by default know something like public domain, so you have to give a specific license out for that. When it comes to licenses and people ask me what I like, I would say something like CC0 would be nice for something like this because it's easy to use. But I think again, I don't specifically remember. I think it was a somewhat custom license stating something like, you can use it in basically whatever way you want to.
Yeah, that's really interesting. Yeah, I mean, I was just curious. Yeah, that it's great that the public, the data is available and usable. But it's interesting. Now we're seeing a lot more of these kind of problems with copyright of data and licensing and stuff. And presumably down the road they might change their license or something. But being that it's scientific data and it's also publicly funded, you would hope that that's going to remain available. So you mentioned a bit before that there's, I think, 6 of you said working on the project. So how many people work on it, and what kind of things, what kind of things are you doing on it?
Well, we have.
Go ahead.
No, not a problem. So we are 6 people actually from the core who started it, who came up with the idea, where we have basically Lars and Sven, who are our senior software developers, I would say, who are doing a lot of the groundwork and where we can always go to ask them stuff how you better implement it. We have some people I am mainly interested in the data science behind it and the organization. Then we have Tina and Hendrik and Simon, who are occupied with writing tutorials and checking that the quality of the whole project is good, and we get more clients, more users actually.
That's great, and you are obviously quite a young project. I mean, 3 months, that's amazing, the stuff that you've achieved in that time, in such a short time. So who knows, in another 3 months you could be, that far ahead again. Who knows? No pressure, by the way. But yeah, it's really interesting, the kind of stuff that that's going on at the moment. And so what's the kind of current state of the project? If you say, I mean, are there bits that are working that are great, and bits that you aren't quite working yet? How's all that kind of stack up? I'm going to direct this one because I realize I keep asking you guys a general question, and then you're never sure who I'm talking to. So I'll try and be a bit more better about that. So Lars, why don't you start us off on that? What kind of stuff what kind of state would you say the project is in right now?
Okay, maybe to give you a little bit of background to this. So we basically have thought about doing this in 3 phases. So first phase was just to, get one of the data sets and trying to visualize it, trying to work with this a little bit and trying to get to know this data. So this was something like 2 or 3 weeks at the beginning. And we were quite happy when we had a GeoJSON at the end, which we could render somehow, and had a map with a lot of, colored points on this. It's basically what it was. So this was our first stage. Our second stage was then, now we basically know the data. Let's see how we can use it. How we can build infrastructure to use it, how we can build algorithms to use it, and stuff like that. But we did not want to start with the whole world and forever. I mean, forever, the satellite is only started in 2017, but even then we wouldn't want to start with 2.5 years or something like that. So we said, okay, let's limit that to, and since we're all here from Germany, we limited that first to Germany, 2019 February, where we said, okay, that's definitely less hardware we need for keeping this running. And we can probably already test a lot of the applications, a lot of the algorithms, and find out what works and what doesn't. And in a way, we are now at the end of this phase. So we know what works and what doesn't. And so, by the way, as part of this, we still imported the whole world at some point, because we wanted to know how much data we have and how much bigger will it get when we import all of it. And we still manage that. But right now we also see that we do have some deficits when it comes to bringing out this data. For example, you mentioned our example on the website earlier, which is relatively new. So it's basically from last weekend. And that's plotting a graph of average carbon monoxide data for country. And if you ask our PostgreSQL database right now about Germany, which is a relatively small country, that's worked pretty well. But if you ask something like United States, or if you ask something like China, that's still very, very slow. Very slow means you still get it in a reasonable amount of time, so you don't have to wait a day, but a minute or so. But for us, that's definitely too slow. So we definitely need to build something that's faster than that. And we already have a number of ideas to how to do it. I mean, an obvious thing, if you just have a number of countries on the world. So what you could do, for example, is do caching. But then we're also interested in having or looking at data in different perspective, maybe calculating some of this data, maybe getting database queries faster. It was really fun at the beginning, where I think for the first time when we imported Germany, we were using an object relational mapper for querying and importing this data, and was the import was so awfully slow that we needed about 2 days to 2 to 3 days to import Germany, for example, for February. And so we took this task and tried to improve this, and now we imported the world in a day. So that's already significantly faster. And now half of the time is actually another performance problem we have right now, and not the import anymore. So we're trying right now to build on this basis where we learned a lot of the lessons and trying to improve this. The second thing I think is that right now we do have a very limited API, and we have a lot of other ideas what we could do with the API. So right now you could get the average, for example, or you could ask it for points for a specific area. But it would also be nice to get areas. There's still, I think, a pull request out there which you can ask for specific points. So for the idea behind this is, for example, to say, okay, for all of the mega cities or world cities in the world, can you give me the emissions data or air pollution data for these cities, and do fun stuff like comparing New York versus Berlin or something like that. And by the way, I already did this with some countries. So I compared Germany to Japan, for example, which Germany did win when it comes to air pollution data. So it does have less carbon monoxide pollution, at least in February, which is really fun. And we're also trying to talk to different people now to see, now we know what's possible. So we can talk to people what they want to have, and we are not fixed on a very specific API. But if someone approaches us right now and says, okay, I have this great idea for emissions data and want to plot it like this, or build a tool like this, we can talk about this, and we can definitely try to build something like this. For example, another colleague of mine working on my main job basically says, okay, maybe we can get a list of big industries and see how much air pollution they throw out basically, or something like that, and then make a digital wall of shame for these companies, which I think was a fun idea. Or we also had a meeting last week with another open source project called the Open Sense Map, which is basically a world map where you can import sensor data and see sensor data compared in different clusters and stuff like that, and trying to do some collaboration and work with these other projects, I think makes a lot of sense, because at the end, I mean, our main goal is to have a stable API which others can use. Our main goal is not providing any end user data, though we may do that as part of examples and stuff like that.
That sounds excellent. And we've got this is topics generating a lot of discussion in the chat room. They're very interested in. They're also debating things like, why is the sky blue? But let's not get into that. That's maybe beyond the scope of this interview. But so we do have a question. I'm going to direct this one to you, Timo. We have a question from Micro in the chat room, who says, how is the data corrected for days when there is significant cloud cover? Can you correct it in some way, or how does that work?
Well, to be honest, at the moment, we do not correct it. So the ESA simply does not provide this data. They provide information about where there is cloud cover, and then it is simply ignored, and we do the same. It's just because we cannot infer reasonable values for those pixels where there are clouds. So that is an important limitation, actually, that has to be taken into consideration when working with this data. So you have this idea that satellites provide this dense data sets of the world where you can, with a good spatial resolution, see everything that is going on. But actually, when you start to work with the data, you get a feeling that there are a lot of missing data as well. So there are a lot of holes in the data. For example, cloud cover. Of course, the satellite passes only over one area one time per day, and so you get a measurement from that time, from that specific specific time. So these are some limitations that this data has and that you just have to be aware of. But this is also something that we would like to try to work on in the future of this project. So we would like to understand better this kind of satellite data. In the end, we are a data literacy project, so we try to make we try to give a better understanding of this data to the general public. So we will try to explain also these kind of limitations better and what you can actually do with this data, how you can analyze it, and for what kind of fact-based discussion this might be useful. So this is something, like Lars said, we are getting started. We are in an exploratory phase. We now have a working proof of concept that can be used, but there's still a lot of work to be done. There's still a lot of analyzing to be done on how actually use this data and what kind of questions you could actually answer with this. But this, to me, is actually really, really interesting, especially when you compare it with citizen science projects, like Lars said before, Open Sense Map. We also have in Germany Luftdaten.info. They have ground data for particular matter. They have sensors on the ground, and now at a very fine-grained resolution, because then you actually you measure just the direct environment, but we will use this data that comes from satellites that is much more coarse, but also, of course, you can have more general patterns that you can infer from it, and also from regions where there are no sensors at all. So we try in the future, we will try to be kind of a complementary data source to these kind of projects, and we hope also to get a better collaboration with these kind of citizen science projects to generate synergies in the end between ground data and satellite data.
Well, we're almost out of time. Yep, my mic's on. For a second, my mic wasn't on. I hate that when I start talking and it's not happening. Is there anything we didn't cover that you think we should have covered? We'll start with Lars.
I guess the most important thing for us right now is if you're interested in the whole thing, and even if you don't want to work on this, but you're in an interest in working or building your own project based on this data, just let us know and talk to us and say, hey, can you provide this data? I mean, worst case, we can just say, no, we can't, or we don't want to. Maybe that's also possible, but talk to us and maybe we can make this work. And that's the whole idea of the whole thing, I guess. And also, of course, if you have infrastructures to spare, we don't mind taking it.
Nice. Yeah. And Timo, some question?
Yeah, I'll double down on that. If you are interested in this topic, just talk to us and work with us. We are a publicly funded project, so one of our main ideas is that we do everything out in the open. We try to be as transparent as possible. We will discuss everything openly and transparently, and so just talk to us on Twitter, Mastodon, or just on GitHub by commenting issues or opening issues or doing pull requests. So I think that for us at the moment is the most important thing. We forgot to be...
Go ahead, sorry.
You forgot to say meet us at open source conferences. So we'll definitely be on the next Chaos Communication Conference. We will be at FOSDEM in Brussels next year in February, and probably also on the FROSSCon in Germany here. So if you happen to be there, talk to us.
Mm-hmm. Yeah, so awesome. This has been a fascinating project. We have a lot more chat than we normally have, which is great. And of course, Dan is really excited by this too as well. And I was able to talk about how I worked on Iridium. That was nice. So, okay, we got two more questions. I think Lars already knows what the two questions are, but I'll ask them again. So, what's your favorite text editor, and what's your favorite programming language?
I don't think it has changed, so I'm very pragmatic about programming language, but since we're using it on the emissions API, it's Python, and for the text editor, it's definitely Vim.
Okay, and Timo, same two questions?
Well, Python is obviously awesome for data science, but I also like R very much. So I'm going to say R as a programming language, and I'm just working Visual Studio Code. So.
Visual Studio Code. I just started playing with that because I need it for my Flutter projects. So that's pretty cool. It's amazing that something that beautiful and that powerful is open source out of Microsoft. This is people would.
That's true.
If I went back 20 years or 15 years and told people in the future Microsoft will be an open source supporter, not a what else is that? When it's sort of shared source, when they tried to be open source in principle only or in yeah. So that was pretty funny. But it's definitely fun. Of course I had to have it figure out where the Emacs key bindings are. So there's an extension I installed that made it all Emacs so that my hands automatically go to the right keys, which is pretty funny. And of course, it means some of the descriptions of things like in the Flutter guides, they say, well, press this key. And I go, no, that's scroll down for me. So it's like, so I have to keep remembering what the differences are. So that was pretty funny. Anyway, it's been great. Good to have you on. And I hope much success to this project. Sounds like you're on the right direction and having good stuff. So thanks for coming on the show and making this project aware to a lot more people. Thanks, Lars, and thanks, Timo.
Thank you very much for having us.
All righty. Cool. That was Lars and Timo talking to us about the Emissions API project, which is it's rocket science, but it's not really because it's just data manipulation. So, yeah. What do you think there, Dan?
I thought it was fascinating. I think some of the stuff we were talking about at the end there, which about education, because they were saying they're a data literacy project. That is amazing because obviously, it's great to get this information out to more people, help them to understand it, so they can contribute to what's going on and develop this stuff. And it seems really good. And I really like the fact that they're getting support from the government as well in this and public funding and stuff. It shows that there's a real value to this.
Well, this is exciting because it's science and it's rocket science. Again, I keep saying that, but it's you don't have to be a rocket scientist. You can simply use the data in creative and clever ways, and it'll get more people excited. Hopefully, bring in more kids, because they can get hands-on and they can have a graph show up in a few minutes, of various products in Germany for now, and then more later. Obviously, when it gets fully rolled out, it'll be a lot more fun. So I think anything that gets kids interested in, using JavaScript, making pretty pictures, and actual science it can only be great. I actually don't know. I'm not going to get political here. I was going to say, not sure this could have been started in the U.S., but all right. No, did I say that? No. Editor, please go back and erase that part of the tape. I don't want to get in trouble with my U.S. science friends. So there we go. Let's talk about who's upcoming. I've added quite a few since in the last 2 weeks. So initially, let's see, immediately next week is, and I don't know if this is the French word chezmoi, Chezmoi. I guess that's chezmoi. I don't even know what that word means.
Moi is me, isn't it?
Sorry,
moi is me. It's me. Yeah. I think it means. So moi is definitely me. So I think it's me.
Okay. All right. And what that does is it helps you manage your personal configuration files, all your dot files across multiple machines. And that's always a problem. And there have been various solutions to that, people using Git, all sorts of crazy things like that. LS Quick is Lightspeed QUIC library. It's an open source implementation of the Quick and HTTP3 functionality for servers and clients. XWiki, which is a wiki, of course, not a former wiki. It's XWiki. Okay, so the first generation wikis were used to collaborate with content. Second generation wikis can be used to create collaborative web applications by using the wiki paradigm and editing wiki pages. XWiki can be used in either the first generation wiki or the second generation wiki, which is cool. Yugabyte. These guys might actually want to look at Yugabyte. Yugabyte is a huge distributed database, multiple continents, multiple masters. and so on. So that should be pretty interesting. They don't have a Postgres interface yet, though. I thought it was distributed Postgres, but it's actually, I found out about it through the Postgres organization, which is why I thought it was already there. Rolla Steam is a virtual tabletop software and helps you manage tabletop role-playing games with remote friends and players. It provides many features to share maps, pictures, and it also includes tools to communicate with your friends and players. So this would be great for people that are like distributed, like dungeon masters. Do they still call them dungeon masters? I don't know. It's been so long. Titan. It makes it easy to run your favorite database in a Docker container on your laptop, but with the power of versioning this on the underlying data. So in other words, you can roll back and forth data just like you can in Git for code. It's really pretty cool. Kong just got added during the last 10 minutes of this show. They're back. It's the next generation API platform for multi-cloud and hybrid organizations. You can connect all your microservices and APIs with the industry's most performant, scalable, and flexible API platforms. Also just added its schedule since last week, Open Mainframe. So the mainframe has evolved to become the most secure and trusted hardware platform on the planet. Open source software has rejuvenated the mainframe as a viable consolidation platform that both saves on licensing costs and enables technologies such as virtualization, cloud, containerization, and cryptography that are built, vital to survive in today's economy. Pretty cool. You can see all these and more, the exact timings of all these shows, at the big spreadsheet, which is listed from the homepage for this show, twit.tv/floss. If you have any other suggestions, please tell the project leader or community coordinator to email me. As you can see, I've got quite a few shows in the pipeline, but I think my next slot is February something, so that'll be coming up. And we have a live stream at 9:30 a.m. Pacific time on Wednesdays at live.twit.tv. I should say usually because occasionally we get preempted. And you can follow us at @FlossWeekly on Twitter. You can follow me at Merlin, MERLYN on Twitter. You can also join us at the forum, twit.community. I'm not getting there as often as I should, but we are creating channels for each individual show and also channels for each episode, and you can post to those and that sort of thing. So I've just been told by the Home Office there's no show either Christmas or New Year's because the studio will be closed. And it's always nice that once every 7 years, I get to take 2 days off in a row, or 2 weeks off in a row. So that's kind of fun. So we won't have any shows on those 2 weeks. I am going to be in Santa Monica all next week. There's a semi-annual ZipRecruiter all-hands meeting where they fly in all the remotes, and then we all have to fight for desks because there's only enough desks for the people that are local. And it turns out about half, I think, of ZipRecruiter's employees are remote. So they fly them all in, and we have a big party at the end of the week. By the way, next Friday is my birthday, so I'm going to, it happens to be the day of the party, so it's really fun. They're throwing a birthday party for me. No, not really. Okay. Anything you want to plug there, Dan?
No, I was just going to say I'm on the, much like you, I'm on the Twit community site, so people can find me on there if they want, and I'll endeavor to get on there more often. I need to really get into that, but it looks really good. Find me on Twitter and all those sorts of places. stanlynch.org. It's easy enough to find.
Sure, definitely. Okay, so wait. Open system references. Why is it making me do that? Oh, because I was trying to move Emacs around. It doesn't want to be moved.
It's an Emacs problem. I shouldn't say that.
Yeah, I know.
It's an Emacs problem.
It's probably Emacs emulating Vim that it's running that way. Anyway, so hey, Dan, thanks once again for joining me and being the co-host, so I can bounce ideas off of you, and we can I can take downtime in the middle of the show, and that's so I always appreciate that when you can do that. So thanks, Dan.
No problem. Always great to be here. See you again soon.
Cool. And we'll see you all again next time on Floss Weekly.